In the previous lecture, we have studied about the first come first serve scheduling algorithm, and we have seen how it works, and we have also solved some problems in first come first serve scheduling algorithm. We also saw that it was very easy to implement, and also we have seen that it had some disadvantages. Now moving ahead in this lecture, we are going to discuss the next scheduling algorithm, which is the shortest job first scheduling. So from the name itself, it is easy to understand that shortest job scheduling means the shortest process, or the process that will require the CPU for the shortest period of time will be the first one to get the CPU. So in case of FCFS, the process that comes first was the one to get the CPU regardless of the length of that process. But in this, the length of the process matters. That means the time that the process will take in using the CPU is matter, and the shortest process in this case will be the first one to get the CPU. So it says here that this algorithm associated with each process, the length of the processes. Next, we say shortest job first scheduling. We don't actually mean the entire length of that process or the entire time that the process is going to take, but what we actually mean is the length of the processes next CPU burst. That means the next time this process is going to use the CPU, how long is this going to take. So for the next CPU burst, what is the length of that process going to be, or how long it is going to use the CPU. So based on that, the process will be assigned to CPU. So the process having the least next CPU burst will be the one who to get the CPU first, and this pattern will be followed for the remaining processes as well. So when the CPU is available, it is assigned to the process that has the smallest CPU burst. So this is what I have explained. When the CPU is available, the process that has the next smallest CPU burst will get the CPU, and then this pattern will continue. Now there may be a question that comes to your mind: if two processes having the same length arrive, then which one first get the CPU? The process is waiting for the CPU and both of them have the same length, then who is going to get the CPU first? And so in this case, the next CPU burst of two processes are the same. FCFS scheduling is used to break the time. So if that kind of a case arrives, if the next CPU burst of two processes are the same, then FCFS scheduling is used to break the time. So that means if two processes having the same length are waiting for the CPU, then this shortest job will be applied. They are both having the same length. So in that case, FCFS will be used. That is, first come scheduling will be used. In the previous lecture, it is used to break the tie. That means the one that arrived first will be the first one to get the CPU, and the next one will get after that. So that is how the tie is broken. In this case, two processes having the same CPU burst are there. So another important thing that we need to know here is SJF algorithm, or the shortest job algorithm, can be either preemptive or non-preemptive. So we have already discussed the meaning of preemptive and non-preemptive. So in the previous algorithm that we have discussed, which is the first come first serve algorithm, we have seen that it was a non-preemptive algorithm. That means when the CPU is being used by a particular process, that process cannot be preempted. That means that process cannot be disturbed until and unless that process completes its execution or goes to a waiting state. No other process can come and disturb it and take the CPU away from it. But in the case of this shortest job for scheduling the algorithm, it can be either preemptive or non-preemptive. There may be cases where it has to be made preemptive, and there may be cases it has to be non-preemptive. So in preemptive case, if one process is using the CPU, then even other process can come and take the CPU away from it based on some conditions. So we will be seeing that when we take the example. So it can be either preemptive or non-preemptive in shortest job scheduling. Shortest job scheduling works, we have to notice that it has more appropriate term for the scheduling method would be the shortest next CPU burst algorithm. The scheduling depends on the length of the next CPU burst of a process rather than its total length. So This is what has been explained in the beginning of the SJF algorithm. So it is called as the shortest job first scheduling algorithm. We are not considering the entire length of the process, but we are just considering the length of the process. Next CPU burst, that means when the process is going to use the CPU for the next time. Why are we saying next time? Because during the course of a process execution, there may be times it will use the CPU, then again come out for some IO operation, and then again use the CPU, and so on. When the CPU burst occurs, that means when the process is going to use CPU for the next time, what is that length going to be, and that is what we actually take into account. So a better term for this algorithm would be the shortest next CPU burst algorithm. But in most of the books we refer, it will be written as shortest job first scheduling or the shortest job first algorithm. But remember that even though it is a shortest next CPU burst algorithm, so we have seen how it works. Now let's see with some examples.